Hello, let me start my recording. And the first task is to deploy the Ocean database. So the easiest way to deploy is from a Docker. So let me run the Docker file. This will pull the latest images from Docker. Okay. It takes some time to download the images. Next, I run the command to start the container. And the container has started. Okay, then we execute the container in the bash environment to start the demo environment. So it takes some time to start the demo environment. Okay, final check. Okay, and it's ready. Let's start a new database connection, connecting to my SQL. And the server host is this, and the port is 2283 database. And then I need the password. This is the password. And let's test the connection. And it's not working. Of course, I got the port number wrong. 2883, let's test the connection again. Okay, this is correct. And finish. Now let's create the database using this command. Create database and run it. Okay, this should be created. So if I refresh the database and I've got this, let's set this as the default database. Now the first thing to do is to create a new table. So we create a table by running this command. Currently, there are no tables. So if I run this command, a new table is created. And this table should be empty. If I run this, you can see that the table is empty. Next, let me insert some sample data. So I run these commands and check that the data is correctly inserted. Next, I would like to create another table and insert the data into the table. And let's check the table that there are some data, yes. Okay, so one way is to insert the data. Another way is to import the data. Let me refresh this. Okay, this is a sales table. I can also import the data via CSV. Next, choose the CSV file with the data. Then it's comma delimited, and target container is James database. And check that the columns are mapped correctly. Next, truncate the data before importing. Yes. Next, and proceed. So when this is done, if we run this command again, we should see, yep, more data populated. Next is to create index. So create the index for salesperson so that the search can be faster. And next is to do data manipulation. Let's try this. Select star from salesperson. So I have 2 person, so let me insert a third person. And you can see that the third person is inserted. Next, let me change the email address. So I edit the email address here. And you can see that the email address has been changed. Next, I can try to delete the third record that I just inserted. And you can see that the record is deleted. Okay, very good. Next, we can check some statistics of the table. So if I run this line, you can see that some statistics from the sales table. And then if you run this line, you can see the stats from the salespersons instead. Salesperson table has a primary key, and the sales table has a primary key along with an index column index key. Next, I will analyze the data using an SQL query. So this query joins both tables, salespersons and to sales, on the common ID column. And I specify a condition that dates must be 2023. So if I run this command, you can see some of the sales volume because I would like to sum up the sales volume. And if I remove this constraint, and you can see the volume has increased. Okay, that's all. Let me go to the PowerPoint to explain the architecture of OceanBase. First, let me change my PowerPoint to laser pointer. Okay, good. OceanBase is a distributed SQL database that is highly scalable and high in performance, and also fault tolerant. So these are its features. It's a database management system that supports both transactional and analytical processing, which is very amazing to be able to support both at the same time. Its transactions follows the ACID principle, and it is based on the PAXO protocol with strong consistency. It is compatible with MySQL, but requires a smaller storage space and has achieved high performance in its benchmark test. And the OceanBase architecture is based on the following key concepts: integrated architecture, whether standalone or distributed. The database does not consume extra overheads. Shared nothing system architecture means each server node has its own SQL execution engine and storage engine. To explain this, it is like the analogy of a business operating in multiple countries, having its own HR, admin, and finance team in each country. So they don't share the HR team, for example. Replication and partitioning stores replicas of each partition on at least 3 server nodes. And this ensures database is highly scalable with redundancies. And MVCC concurrency control, it allows read-write data consistency, like updating. It's like when we are using OneDrive or shared Excel, if I update the file from my laptop or you update the file from your laptop, we should get this to see the same data concurrently. And compatibility and scalability, users can migrate businesses from MySQL or Oracle, either an upgrade from MySQL or a cost reduction from Oracle. Now this is just an overview, but the most important point is, what do customers want? Always listen to our customers. Customers want data to be available, usually accessed from the nearest data center from various regions, Asia, Europe, or America. And customers want data to be consistent and correct, and regardless if the data is accessed from USA or Asia. And customers want data to be scalable and accessed from anywhere in the world, as well as backed up. It's challenging to achieve all 3 aspects Just like we want products to be good, cheap, and fast. If a product is cheap and good, it may not arrive fast. If a product is good and fast, then they may not be cheap. Let me explain the triple constraint in CAP theorem. Availability is what customer wants in low latency. Consistency means accurate data. And partition tolerance is for scaling. So it's the same as the previous slide, what we have. And this triple constraint in database design means at any time, we can only achieve 2 out of the 3 aspects in practice. Now to get CA is simple. We just need to store everything in one location, no partition. Where there is a partition in the distributed system, the CAP theorem states that one must choose between consistency or availability. Now CP is achieved at the expense of availability because it takes time to sync the data. And AP is achieved when all data is readily available, but you cannot guarantee that the data is most updated. Now the good news is OceanBase has managed to achieve all 3 aspects and offer them to customers. They solve such a physical problem using software or algorithm. Now let me explain an example of solving a physical problem using software. In the 90s, when music technology transits from magnetic conduction to optical induction, there was a big problem implementing it in cars. Because whenever the car hits the hump or some unevenness on the ground, the optics will not be able to read the compact disc and the music will skip. The solution is a software solution, quite clever, that is to read the data in advance and then you play from the memory. So this ensures smooth music without disruption. Likewise, OceanBase has also implemented its self-developed storage engine, which is its own proprietary asset. Its standalone engine uses the best RDBMS technology. Its distributed engine uses some interesting algorithm to efficiently handle mixed loads such as hybrid transactional analytical processing. It features cutting-edge compression technology for storage that requires only a small storage footprint. Its synchronization uses various types of merging, and its technology enables data to be available and consistent, which is also its proprietary intellectual property. These trade secrets are briefly explained in the Alibaba blog here. I've also made a comparison on the competitive landscape between OceanBase, MySQL, and Oracle. Oracle is the oldest and most established, followed by MySQL, who eventually got acquired by Sun Micro and Oracle, and then OceanBase is the most recent. MySQL and Oracle are very similar and considered as standalone RDBMS, except Oracle supports a distributed system to some extent. Oracle and OceanBase are widely used in enterprise deployments and enterprise environments, whereas MySQL is used by small to medium-sized businesses. In summary, OceanBase is like a big library where you can store a lot of books or data. But instead of having one librarian and one data center, there are many librarians working together to help you find the information or the data you need. Now, each librarian or data center has its own zone of the library, and they take care of and they know the zone very well. So when you need to find something in the library, you go to the main librarian and ask for help. And the main librarian knows which zone of the library has the information you need and will give you a map to follow. So you go to each zone to approach the librarian and he will get the information for you. Now, OceanBase is good at keeping the information safe and making sure we can always find it. Even if one zone is burned down, it's like having a lot of copies of the book in different parts of the library. So if one copy gets lost or damaged, you can always find another copy. And that's all I have. Let me know your feedback. Thank you.